These are the first 5 problems on the study guide for Algebra B, Test 6 of Quarter 2. So let's take a look at the first one here. And on this one, we are asked to simplify an expression that has some fractional exponents. So what we learned about fractional exponents is that the denominator represents the number of roots, and the numerator represents the power. And so when we do this, we've got the square root of 25, but then we're raising this to the first power. So the 2 represents the number of values that multiply to make this base, or this radicand. And then we're going to add on the cubic root of 64, again all raised to that first power. So go ahead and do some work there. The 2 numbers that make 25 are 5 and 5. Again, whenever it's an even number, well, you try even numbers. For odd numbers, you try odd numbers. And so now we're looking for 3 numbers that make 64. They all have to be the same, and they have to be even as well. So it ends up being 4, and 4 to the first power is just 4. So we add those numbers together, 5 and 4, we end up with 9. That would be our answer. Well, the next one is going to see if you understand what to do when it has a power other than 1. So it's the same sort of process. We just take 2 numbers that multiply to make 25. But then we're raising this all to the third power. So those 2 numbers that make 25, well, as we saw before, that was just 5 and 5. But at the end, we have to bring that to the third power, so it's 5 times 5 times 5, which makes 125. Well, the next problem follows the same sort of thing, except we're going to end up with a fraction, and we've got to bring this fraction, both numbers, see the 9 is to the first power, the 16 is to the first power, but we're going to bring both to that 3/2 power. So it's basically 2 problems in one. So we've got our initial part that we'll write out, the second root of 9. So we're looking for 2 numbers that multiply to make 9, but we're raising that to the third power. Down below we do the same thing, 2 numbers that make 16, but we're going to end up raising this to the third power. So both numbers get put to that power, just as we would with any problem that involved that outside parenthesis. So we go ahead and do the work here. Square root of 9 is 3, but then we bring that to the third power. The square root of 16, 4, but then we bring that to the third power. And we multiply out those 3's. So 3 times 3 times 3, well, that's 27. 4 times 4 times 4, that's 64. There is our answer. Well, the next problems are going to ask us to either add a polynomial, and then 5 is subtracting a polynomial. So when it's adding, there's nothing to do except to line up the terms. I like to use that column method. So I'm going to take the 4x squared, put it underneath the term I'm going to combine it with. Take the negative 2x, put it underneath the term I'm going to combine it with. Take the negative 9, put it underneath the constant, and then add the numbers together. Well, if they're the same sign, you're going to add. Like these are the same sign here, they're both positive, so we count them up. 3x squareds and 4x squareds make 7x squared. Here they're the same sign as well, so they're both negatives. So it's a negative 1x plus a negative 2x makes a negative 3x. Here they're opposite signs. One's positive, one's negative. So we end up having to subtract more negatives than positives, so that's why it's negative 3. And there's our answer. The next problem is going to be a subtraction problem. So what you're going to want to do is you're going to want to change it to addition. So the way we do that is thinking of this as like a negative 1 here. We're going to distribute a negative 1 over all of these numbers. So every number is going to change signs. So change it to an addition problem. That means changing all the signs in that second set of parentheses to their opposite. Once you do that, it's the same process as number 4. You just line up the terms. So making sure that we're lining up the ones with the same variables and same exponents. So it just so happens that we have another x to the third term here, the negative 5x to the third. We've got a positive 6x, and we have a negative 9. Now, if we didn't have an x term, we wouldn't line it up with the term here. So be very careful. Make sure you've got the exponents lined up. Every term is exactly the same type. They're like terms, we call them. So we go ahead and add these numbers together. Again, if they're the same sign, you are going to add. If they're opposite, you will subtract. So negative 3x to the third is what we get when we combine these two. One's negative, one's positive. So we subtracted more negatives than positives. Over here, more positives than negatives, so we're going to end up subtracting again, but we have a positive x, or positive 1x. Here we are going to add because they're the same sign, and the sign will stay the same, so negative 17. And there would be our answer. So those are the first 5 problems. Part 2 will have the last 4 problems.